Question 18. For every 2 correct answers, 7 marks will be rewarded. For every 2 wrong answers, 5 marks will be deducted. So, what do they mean? For example, if Alan answered 2 questions correctly, he would receive 7 marks. If he answered 4 questions correctly, he would receive 7 times 2 equals to 14 marks. So, what happens if he answered any questions wrongly? We know that for every 2 wrong answers, 5 marks would be deducted. So, if he answered 4 questions wrongly, a total of 5 times 2 equals to 10 marks would be deducted. Let us further test our understanding of the problem. Suppose Alan answered 80 questions correctly and 20 questions wrongly. So what would be his total score? For the 80 questions answered correctly, the marks rewarded would have been this, which gives us 280. And for the 20 questions answered wrongly, the marks rewarded would have been this, which gives us 50. So his total score would have been 280 minus 50, giving us 230. With that in mind, let us proceed to solve the problem. Part A and Part B require us to find the maximum and minimum possible number of correct answers. So, we need to examine the conditions under which these 2 values can be attained. So, suppose there are 10 questions answered correctly, so the marks awarded would have been 35. And let us further suppose that there are 6 questions answered wrongly, so the marks deducted would have been 15. Since there are a total of 100 questions, if 10 are correct, 6 are wrong, the rest must be unanswered, giving us a total of 84 unanswered questions. Since no marks will be rewarded or deducted for any unanswered questions, the marks awarded would be 0. So the total score would be 35 minus 15, giving us 20. Suppose we increase the number of questions answered correctly to 20 while keeping the total score fixed. So with 20 questions answered correctly, the marks awarded would be this. After several trial and error, we notice that in order to keep the score fixed, we need to increase the number of questions answered wrongly to 20, giving us 50 marks deducted, and also decrease the number of unanswered questions to 60 in order to keep the total score fixed. If we further increase the number of answers which are correct, we have to further increase the number of questions answered wrongly and further decrease the number of unanswered questions while keeping the score constant, as indicated here. For example, if we increase 10 to 30, there is an increase in the number of answers which are correct, but along with it comes with a decrease in the number of unanswered questions and an increase in the number of questions answered wrongly while keeping the score constant. So from the table, we conclude that given a score, if the number of questions answered correctly increase, the number of unanswered questions would decrease, and if the number of questions answered correctly decrease, the number of unanswered questions would increase. In Part A, we are supposed to find the maximum number of correct answers. Earlier, we have observed that whenever the number of correct answers increase, the number of unanswered questions would decrease. So, to find the maximum number of correct answers, we may assume that the number of unanswered questions is 0. We can solve Part A by using the systematic guess and check or the assumption method. We can start off by using the systematic guess and check method. We can start by assuming or guessing the number of answers answered correctly. We can try 80. So given 80 correct answers, the marks awarded would be 280. Since there are a total of 100 questions, if 80 questions are answered correctly and there are no unanswered questions, the rest of the questions must be answered wrongly, giving us 20. and the marks deducted from these 20 questions would be 50. Hence, the total score would be 280 minus 50, giving us 230. We know that this is not his total score because his total score is 266 and 230 is smaller than 266. So we should try to increase the number of questions answered correctly. In this case, we try 82. So for 82 correct answers, the marks awarded would be 287, and the number of questions answered wrongly would be equals to 100 minus 82, giving us 18, and the marks deducted would be 45. And the total score would be 287 minus 45, giving us 242. Again, this is not 266. However, we notice that we are getting closer to 266 by 12 marks. So if we increase the number of correct answers to 84, to which time, based on our prediction, the total score must have also increased by 12, giving us 254. If we further increase our correct answers by another 2, giving us 86, based on our prediction again, the total score must have increased by another 12, giving us 266 as indicated in the question. Hence, the maximum number of questions answered correctly would be equals to 86, and the answer for part A is 86. Now, let's use the assumption method to solve part A. Again, we assume that there isn't any unanswered questions because we want to attain the maximum number of correct answers. So we can start by assuming all questions are answered correctly, which means the total score would have been 350. However, his total score is equals to 266, so there is a deficit of 84 marks, which means he must have answered some questions wrongly, resulting in a loss of 84 marks in total. So our goal is to find the number of questions answered wrongly. From there, we can find the number of questions answered correctly. So suppose I replace 2 correct answers with 2 wrong answers. There would be a loss of 7 plus 5 equals to 12 marks. Why? Because if these 2 questions are not answered correctly, there would be a loss of 7 marks, and if they are answered wrongly as well, a further 5 marks would be lost, giving a total loss of 7 plus 5 equals to 12 marks. If I replace another 2 correct answers with another 2 wrong answers again, there would also be a loss of 12 marks, so on and so forth. We know that the total loss is equals to 84 marks as a result of answering some questions wrongly. So the goal is to find out how many pairs of correct answers are being replaced by how many pairs of wrong answers. We can do so by taking 84 to divide by 12 to give us 7 such pairs, which means that we have replaced 7 pairs of correct answers by 7 pairs of wrong answers. Therefore, the total number of wrong answers is equals to 7 times 2, which gives us 14. Hence, the number of correct answers is equals to 100 minus 14, giving us 86. Therefore, the answer to part A is equals to 86. Now, for part B, we are supposed to find the minimum number of correct answers. Recall that whenever the number of correct answers decreases, the number of wrong answer would also decrease. So in this case, we may assume that there isn't any wrong answers. Again, we can solve part B by using the systematic guess and check method or the assumption method. Let us proceed with the systematic guess and check method. We can start by guessing the number of questions answered correctly. In this case, we try 80, giving us a total score of 280, and we know this is not correct because his total score is 266 and 280 is too big, which means that we should reduce the number of questions answered correctly. In this case, we try 78, giving us a total score of 273. Although this is also not equal to 266, but we notice that we're getting closer by 7 marks. So if we further decrease the number of correct questions by 2 to 76, based on our prediction, the total score must have been 273 minus 7, giving us 266. Hence, the minimum number of correct answers for part B is equals to 76. Now, we can also solve part B by using the assumption method. Again, we assume that there isn't any wrong answers in this case. So, the first step, we assume all questions are correct. The total score would have been 350. However, his actual total score is equals to 266, so there is a deficit of 84 marks, which means he must have left some questions blank, resulting in a total loss of 84 marks. So our goal is to find the number of blank questions, and from there we can find the number of correct answers. Observe that given 2 correct answers, if I replace it with 2 blank answers, there is a loss of 7 marks. If I again replace 2 correct answers by another 2 blank answers, there is also a loss of 7 marks, so on and so forth. I know that the total loss is equals to 84 marks as a result of leaving some questions blank. So the goal is to find the number of pairs of correct answers that are being replaced by the number of pairs of blank answers. To do so, we can take 84 to divide by 7, giving us 12 such pairs. So this means that 12 pairs of correct answers are replaced by 12 pairs of blank answers. Therefore, the number of blank or unanswered questions is equals to 12 times 2, giving us 24. Hence, the number of questions answered correctly is equals to 100 minus 24, giving us 76. Therefore, the answer to part B is equals to 76.